Hello, this is Mr. Win. Today's video will be multiplying matrices. So again, matrices are very helpful for solving lots of things, including systems. We're almost there, but right now we're just multiplying matrices. Make sure you keep two things in mind. Order does matter. And the second is make sure the middle numbers must match. So the columns of the first one and the rows of the second one. For example, if A is a 2 by 3, so 2 rows, 3 columns, I'm trying to multiply that by B, and B is a 3 by 2, so 3 rows, 2 columns. That's fine because these middle numbers, those 3's, they match. I would ignore that. And my answer, I know, would be A, B, and it would be a 2 by 2. The remaining numbers tell you the remaining size. Now if I tried something else, say I tried C is a 2 by 1, I'm trying to multiply that by D, which is a 2 by 2, these middle numbers do not match, so I cannot multiply them. This is no solution there. Alright, so the middle numbers must match. The first and last one can be anything they want. So find x times y. If x equals that, y equals that. So x is a 2 by 2. Y is a 2 by 2. The middle numbers are 2 and 2. They're good. So I know I can multiply this. So multiplying is kind of weird. You've never seen it before. This case is a special trick or technique. So here's the technique, and I'm going to use different colors to show it. Alright, we are going to do, for the first one, we're just caring about the rows. We're going to do row by column. Alright, row times column. This row is going to multiply this column. So the first number is 6 times -5. Plus, or minus, your choice. I'll say, because that's -3 times 3. That's my first number. And I'm going to distribute that in a little bit. Now, after I finish that first one, I'm not going to multiply that first row again, the 6 and -3, by the second column. That's the top right. So that's 6 times -4 minus 3 times 3. Alright, now I'm going to try again for the other one. Second row times first column. So -10 times -5 minus 2 times +3. Now do the second column, same row. So -10 again times -4 minus 2 times 3. And now I just have to simplify that. So it's your choice. You want to do it all at once or whatnot. So 6 times, I'll do it step by step. 6 times -5 is -30 minus 9 for that top left one. For this top right one, I have -24 minus 9. For the bottom left one, -50 minus 6. Sorry, +50 minus 6. In the bottom right one, +40 minus 6. So my answer needs to have single numbers for each spot. So the top left will be -39. Top right will be -33. Bottom left will be 44. Bottom right will be 34. That is my answer. So as you notice, for the first matrix, only the rows matter. For the second matrix, only the columns matter. So it's row times column, then that same row times the next column until there's no more columns. Then once you're out of columns, you go to the next row. Alright, so that was a 2 by 2 times a 2 by 2 gives us a 2 by 2. Alright, example 2, find this. So G is a 2 rows, 3 columns. H is a 3 rows, 2 columns. When I do G, so 2 rows, 3 columns, times H, that's 3 rows, 2 columns, that is fine because I see those middle numbers, 3's are there. I'm going to cross them out. Our final answer should be a 2 by 2. Alright, so I know it's going to be a 2 by 2. So let's do G is 1, 3, negative 5, 4, negative 2, 0, times h, 2, 3, negative 2, negative 8, 1, 7. In the same process as before, I know my answer is going to be a 2 by 2. Let's give myself a lot of space. So the first row of G times the first column of H. So 1 times 2 plus, let's pause at 3, times negative 2. And that's the negative, so minus 5 times 1. So 1 times 2, 3 times negative 2, negative 5 times 1. Now I did the next column. That's going to be 1 times 3 plus 3 times negative 8 plus, and I'm out of space, so let me do this. Can I shrink this? Alright, so 1 times 3, rewrite this one. Alright, so you can see a little better. Alright, 1 times 3, 3 times negative 8, and negative 5 times 7. Alright, that's my first column done. Now I do the second column. I'm going to do this times the first row. Sorry, column. Second row, first column. So that is 4 times 2, negative 2 times negative 2, and then plus 0 times 1. Other side would be the other column. So again, 4 times 3 minus 2 times negative 8 plus 0 times 7. Now, if you notice, the numbers in parentheses stay the same. So these are still the same 2s. These are still the same negative 2s. These are still the same positive 1s. These are the same positive 3s, negative 8s, positive 7s. The numbers in parentheses will not change. It's just the number in front. Alright, so now I'm going to simplify each one. I'll do it step by step. So that would be 2 minus 6 minus 5. Over here, that's 3 minus 24 minus 35. This is 8 plus 4 plus 0, which doesn't mean anything. This is 12 plus 16 plus 0, which doesn't mean anything. So my final answer for this would be 2 minus 6 is negative 4, minus 5 is negative 9, 3 minus 24 is negative 21, negative 21 minus 35 is negative 56, 8 plus 4 is 12, 12 plus 16 is 28. That's my answer. Alright, so I know G times H. I'm going to go over here. G times H, the answer is negative 9, negative 56, 12, 28. So we're going to keep that in mind. Now, let's try the second one. H times G. I'm going to flip around and do backwards. So let me move this right here. That's G times H. So now doing H times G. H we know is a 3 by 2. Times G we know is a 2 by 3. Now this is allowed because, again, the middle numbers match. Those 2's. Now I'm going to cross them out. When I multiply this, I'm going to end with a 3 by 3. Now that's bigger than we've usually seen. And just from that, we know that G times H is not the same as H times G. So let's try it. H says 2, 3, negative 2, negative 8, 1, 7 times G. G is 1, 3, negative 5, 4, negative 2, 0. So same idea we've always done. So first row times first column. So 2 times 1 plus 3 times 4. Now I'm going to do the first row again times the second column. I'm going to run out of space really soon. So this is 2 times 3, and that is positive 3 times negative 2. And I'm going to move this actually. That did not go too well. Alright, I'll just rewrite it over here. Here, let me go over here. So 2 times 1 plus 3 times 4, and then 2 times 3 plus 3 times negative 2, and then the last one, third column, so that would be 2 times negative 5 plus 3 times 0. So I finished the first row, onward to the next row. This row times the first column, so that's negative 2 times 1 minus 8 times 4. Right, next column, so that's negative 2 times 3 minus 8 times negative 2. In the last column, negative 2 times negative 5 minus 8 times 0. Alright, and lastly, the last one, so 1/7 times the first column, so 1 times 1 plus 7 times 4, 1 times 3 plus 7 times negative 2, 1 times negative 5 plus 7 times 0. So I filled everything out. Time to start simplifying. So this is very simple, so I'm going to go straight for it. For the top left, 2 times 1 is 2. 2 plus 3 times 4 is 12. 2 plus 12 is 14. That's the answer. This middle one for top, 6 minus 6 is 0. Negative 10 plus 0 is negative 10. Negative 2 minus 32 is negative 34. Negative 6 plus 16 is positive 10. I was right, plus 10, but just 10 is already positive by itself. Positive 10 minus 0 is positive 10. 1 plus 28 is 29. 3 minus 14 is negative 11. Negative 5 plus 0 is negative 5. That's my answer. So notice G times H was a 2 by 2. H times G is a 3 by 3. So you need to know the commutative property of multiplication does not work. Doesn't hold true. So before, you remember we had 2 times 3 was the same thing as 3 times 2, right? So that's 6 equals 6. Here, I just proved to you that G times H was not the same as H times G. Matrices work a little different than just regular algebra math you've done. Alright. Does distribution work? I'm just showing you right here. J times K plus L. They just fix K plus L, add like normal, then they multiply it, you can see them do all the work, and they end up with this answer. Then they tried distributing, so they actually did JK and then times JL. Well, multiplication is a lot of work, so they did all the work steps, and they ended with this answer. Notice they're exactly the same, 6, 14, 1, negative 11. So distribution still works, that's never going to go away. Now here's the practice problem. Try it, try U times V. You should get that answer down there. If you can do that, you should be fine for the quiz in class. Again, this is Mr. Nguyen. Thanks for watching. See you in class.